Now, this particular project is one that I saw some photos of a little while ago, and I'm very excited to see it in the flesh, as it were. So next up, we have Peter talking about his Kerbal Space Simulator program hardware.
I feel really bad giving this talk because people have been building ECUs and real-time operating systems, and I've been playing games. But this is a build that I've been working on for a little while, and I thought it might be fun to talk about how I got to this point and some of the problems that I had on the way. This is the game I've been playing. It's Kerbal Space Program. Yes. You can tell the KSP players because they're salivating right now about trying this later. But for the rest of you, it's basically a spaceflight simulator. It gives you a kit of parts that you use to build rockets and things. You crew them with these adorable little green things called Kerbals, and then you fly them around a fictional solar system. I've been playing KSP for quite a while. I've been building weird little projects with Arduino for quite a while. I combined the two when I noticed a emerging hardware modding sub-community on the KSP forums and thought it might be fun to grab an Arduino, a couple of lights, a button or two, see what I could make. Time has passed, and this is where I'm up to. That build has 3 microcontrollers in them, a Mega, a Pro Micro, and a Teensy 3.2. This is the order that I built them in. I like the fact that my microcontrollers get more and more powerful as time passes. I've written about 2,500 lines of Arduino code. Some of it I've stolen from other people, borrowed from other people. A whole bunch of inputs, a whole bunch of outputs. The most recent addition is an LCD display right there. It's taken me 2 years, and I try not to think about how much it cost. Probably around 5-ish hundred Australian, plus or minus 20%, I don't know. So, as I mentioned, I have 3 microcontrollers. The way that I'm talking to them, so I've got a video game, I've got a plugin on that video game that will send telemetry data over a serial connection, also receives data back, and I've got my Mega there that is handling that serial connection, and all of my inputs, or most of my inputs are plugged into that as well. A little while later, I added the Leonardo compatible little micro stick there. It's running all of the LEDs, and the most recent part that I'm still working on only over the last few months now is a Teensy 3.2 that is doing 3D rendering on a little LCD display. So, what have I got? Okay, the way that I got started on this with my one little Arduino, it is, yeah, an incredibly agile methodology really to bastardize a buzzword. And I made a big list of everything I wanted to do, grouped them into logically similar components, and this is one of them. That's pretty much the first panel I did, the stage panel. There's a nice big red button that you mash to launch. There's a lock so that you don't mash it accidentally, an abort switch, and a little status light. So that's the stage one. If you have a look at it later, there's lots of other ones that are all roughly similar in what they do. The reason that I wanted to do it that way is that I could build these one at a time. And there's a dozen of these panels, and they're literally spread over several months. And I documented absolutely every step of what I was doing. Somewhere in my repository right now, there is a text file that says everything related to building one of these panels. It's how I prepared them. That's 3mm perspex, translucent perspex that has been painted and then etched and cut in a laser printer. And I've got documentation about the fonts and the font sizes, about all of my mounting holes and how big they should be, the radius on the fillet. All of that is written down. And the reason I wrote all that down is that I've got panels that I built 15 months after this one, and I was able to spend 5 minutes reading my documentation and punch out something in an afternoon that looks identical to everything else. So that was fun. So I built this one. A couple of weeks later, I built another one. A couple of weeks after that, I built another one. And then I grabbed a scrap of perspex from my local makerspace, cut some holes, mounted what I had, plugged them all into an Arduino, banged out an awful lot of code, and then it was working. You get to that point and then you go, this is so cool. And then you stop building anything and play the game for a while. So I stopped building and played the game for a little while, and then I started building a couple more panels, and then a couple more panels, and then I grabbed some more scrap perspex, knocked together another thing, and mounted them all, and that was that. And then I stopped building them for ages, and I literally had that panel with this one sitting in front of it, looking absolutely awful on my desk, and sat there and did nothing else for nearly 9 months. But then I started getting bored and started wanting to try something else. This is where it gets really complicated. The displays that are on the front there, I made 4 of these LCDs here. And they're really simple. There's a 7-segment display, illuminated buttons, and some LEDs on the side there, with a 26-pin ribbon connection back to here. So there's 4 of those there, using the Max 7219 display drivers, which are really, really awesome. 3 of those chained together, driving that 160-odd LEDs on the boards, and then an input multiplexer, and mounted the SparkFun on the side. I procrastinated on this for a long time because those boards are kind of expensive. I'm not trying to dissuade you, but I am going to tell you how awfully wrong they were. So eventually, yeah, I closed my eyes and hit the buy button and wandered off. While I was waiting for those boards, I started worrying about how I was going to talk to them. I chose I2C for a couple of reasons, mostly because I have one master sending data to multiple slaves, and I wanted it all happening at the same time. I2C, no one seems to talk about it very much, but I2C has a broadcast mode. If you fire packets off to address 0, then in theory everything will pick it up. In practice, the library I'm using on the Teensy doesn't support that yet, so that was really bad. The other reason that I chose it is that AVR chips have a really nice hardware I2C module that they call TWI because lawyers. And it's interrupt driven. It's really, really easy to write asynchronous handlers for it. And if you read Atmel's application notes, they've gone ahead and done that for you. So, however, the Arduino environment wraps all of that in a wire library that is awful. They use a 32-byte packet limit, which made me sad because my current iteration of my data packet coming out of the game is 209 bytes. And it takes all of that wonderful interrupt-driven asynchronous interfaces and hides it behind a very nice blocking interface for you. So I had to choose between using the wire library and having my code loop through my packet 8 or 9 times and block for the entire time. Or I could write my own library, and that is what I did. So I have a library right now that is basically, right now it's just a thin wrapper around those application note interfaces. So while I was waiting for my boards, I wrote that library, tested it with my 2 boards and with my 2 Arduinos, and that was all well and good. Then my boards arrived, and I immediately noticed that they suck. I was using footprints from SparkFun. Buying gear from SparkFun is really nice because they provide Eagle components for most of their parts. That LCD display that 7-segment display has a really bad bug where the footprint in the library is half an inch shorter than the actual part. So I designed my boards. I luckily cut the panels separately and measured them using the actual data sheet for the part. And then it looked like that. That's really easy to fix though. You just kind of mount your LEDs with a little bit of gap on the legs and then bend and twist. And if you have a look at those displays later, you'll see the LEDs are kind of, but it works. So that was fine. I started populating these boards. I soldered on the ribbon cable connectors. I made up some nice long ribbon cables and I hooked it all up, grabbed my multimeter with the continuity tester and started testing the connections between them. Very soon found that half of them didn't work. No discernible pattern that I could see to those until I traced back the schematic and discovered that I had rearranged half of these. That was awful. The reason that I did that, if I jump back to here, This board is all routed by hand, and I'm really proud of that. This one, I went no bugger that, and used the auto router. And so I would run the auto router, look at it and go, it'd actually be a lot simpler if I swap these parts around or flip this one upside down. And somewhere along the way, I decided that it would be much easier if I switched those connections and only did it on one end. So that was actually really awful. I was incredibly sad about that, and that was the worst part of it. I just thought, I've wasted this $150. I'm going to have to throw it all away. I'm not going to have it ready in time for the Sydney Mini Maker Fair, which I had this running at as well. And yeah, pit of despair there. Turns out that once you think about it a little bit, you can actually fix it. It's just awful. Really, really, really awful. I went down to my makerspace with my cables in my hand and spent a solid 10 hours cutting up those 26-pin connectors and splicing them all back together again. I invented new swear words. I hated the entire world. Sorry? You're doing my next ones then. I am proud of the fact that I got to the end of them and every single one of them worked first go. Otherwise, I would have just set fire to all of them. But got those soldered together. I have time so I can tell you the one other bug where I actually completely forgot to solder up one of the LEDs. So for a while, the decimal point just didn't work at all. So my board on the back of it now has some dodgied up connectors. But that was the second part, and once I sorted all of that, it came together really well. I wrote another library, they're 4-digit 7-segment displays, so I wrote a library that will take a floating point number and render it down to engineering notation. And so all of the numbers that you see on there right now will nicely scale from 0 up to multiple billions, which is what you really need for a game that's in space. And that brings me to the next part that I only recently started no, I can tell you about the enclosure, but there's not much to say because it's really boring. It's just 12mm MDF. I used cutouts for the panel designs, cut out from paper as a template to cut holes in the board, painted it all up, and then screwed everything together, and it looked like that. That's really simple. Third phase, I'm still working on this. I've only started a couple of months ago and it's really, really hard. The game gives you a little flight direction attitude indicator, although it doesn't call it that, it calls it a nav ball. I have a teensy that is running some 3D rendering code that somebody else wrote, a nice little GPL piece of code. And it's rendering that. It's very incomplete at the moment. I need to add all of the extra little icons that the in-game display adds. Getting them out of the game is proving to be a real challenge to someone like me who's never programmed Unity 3D before. And that's it. That's how I did that. I'm running early.
But I'm sure there are many questions.
Can we see it run?
It's running right now. I don't have anything, I don't have a radio. If I had like a camera set up, that would probably be a lot better, but.
How did you actually integrate with the game itself?
It's a very, very easily modded game, and there's a huge and active modding community around it. I'm using a plugin called KSP Serial IO, and yeah, literally all it does is grab a bunch of telemetry, put it in a very simple data packet, fires it out a serial connection. And there's an even simpler data packet for receiving data back in, which it converts into commands in game. There are a couple of other ways to do it. There's something that I'm really fond of called KRPC, which gives you a WebSocket connection, and there are several APIs or several bindings for that in different languages. So you can write some Python code. You can write a Python-based autopilot, or you can do some other magic and have your controller talking to that web socket. The other one that's worth talking about is called Telemarcus, which is, again, a WebSocket-based connection.
Thank you. It looks like you have lots of buttons on your console there.
I really wanted a lot of buttons.
What are you programming them to do, and can you reassign them to do different things?
I can't program them to do different things. I was going for a really 80s sci-fi kind of a vibe. So while there are a lot of buttons that cover most of what you want to do in the game, they are not reprogrammable.
Okay, so they're like action groups.
I have, yep, there's the action groups right there.
Yep, so only 10 for the moment.
I didn't find out that you could have more until after I built that.
So is that gap just for notes?
Yes,
Okay.
these are custom action groups, and I wanted something that I could write down what they do.
That was the whole question, because that layout seemed asymmetric. Which is so neat.
There should be.
No notepad.
There should be a little clip on there, but I took it to the Mini Maker Fair, and about 1 billion small children had a go at it, and the clip did not survive.
How long has it been since you last played KSP, and are you itchy yet?
Yes. Yeah, like I said, I take breaks where I do nothing else, but pretty much all of the time that I've logged in it the last 6 months or so has been testing this stuff. Yeah, I'm hanging out for 1.1 soon, so.
Any more questions? Yeah.
So with your action group buttons, do they have lights in the back as well? Can you get them to light up?
Oh man, I screwed those up too. It took me ages to find the style of button that I wanted, and I wanted them to be illuminated. They're the first ones that I found, and I finally went, yes, finally, buy. They came, and I realized that they're 250-volt lights.
So potentially yes.
Potentially, yes. Probably quite briefly, though.
So, Peter, does the console make the game easier?
Easy. Yes, some of the information I'm showing is actually really hard to get. Like, you don't get out of the game unless you're modding it. And there's other bits of information like your orbital periapsis and apoapsis that you can only get for switching screens to somewhere else. So this means that I can fly with one view and get data that I can only get from other views. I am really, really close to being able to fly simple missions with the monitor switched off. That's my end goal. Not quite there yet.
Okay. Oh, yep. One last question. Yep.
Related to that, do you play IVA only?
That's my other big goal with this one. And I think it comes back to I haven't had enough time to practice yet. I have done an IVA only MUN landing. Internal view. So a cockpit view. I don't have a screenshot handy, but there's two views, like external looking at your rocket and then internal from the point of view of the Kerbal sitting in the cockpit. And that's the one that gives you the least amount of information, which is why that's really handy.
Great. Well, thank you very much, Peter.